Welcome back, guys. This is going to be an introduction to Chapter 10. And the idea behind this is really to give you some context at where Chapter 10 is going. How does it relate to what we've been doing? What's the ideas of it? Kind of the foundation. Okay? So Chapter 10 is all about this thing called hypothesis testing. Hypothesis testing. And let's talk about where we've been. So what we've been doing is these things called confidence intervals. The idea being we don't know a population parameter. We don't know our value, whether it's a mean or a proportion. You got probability, percentage, whatever. We don't know the population value. I don't know the average length of all the fish in the pond. So since I don't know that value, is there a way I can predict it? And what we did is we created these things called confidence intervals. And what the confidence interval did was it used sample data, specifically a sample statistic, to estimate the population parameter. And what it did in doing that is it looked at the sampling distribution. It looked at a distribution of a statistic. So for the fish example, we would look at a bunch of sample means that made the distribution of sample means, and we would use that to then create this interval that we would say, I am 95% confident that the population mean is between blank and blank, or I am 95% confident that my specific interval contains that population mean. And that was the idea, predicting the population parameter. Hypothesis testing is a little bit different, though. And I think the best way to describe it is through an example. So let's say I'm going to use the example of flipping a coin. So let's say we're playing a game where you're guessing how many heads I get out of 100 flips. Okay? Well, what you have here in the red circle is the population of all the times this coin is flipped, okay? It's the probability of getting the population all the times the coin has been flipped. And so we know that the population, or you probably know, that the probability of getting heads out of all the times the coin is going to get flipped is 50%. Now, this is different from Chapter 9 because we didn't know our population parameter. We didn't know the average length of a fish in the pond. In Chapter 10, we're going to have a value, a traditionally held value that we use as the population parameter. Okay, Chapter 9, we don't know the population parameter. Chapter 10, we have a traditionally held value, right? We have an understanding that when I flip a coin, there's a 50% chance that I get heads. Okay? And so let's say the first 100 times I flip the coin, I end up getting 47 heads out of the 100 flips. So what that would mean for us is there was a 47% chance. My sample probability in that 100 flips, there was a 47% chance that I got a heads. Okay, that's our sample probability. Okay, and the idea is, right, I could do another sample of 100 flips, and maybe that time I got 53 heads. Or I do it again, and maybe I get 42 heads. Right? We could get all these different sample probabilities. Okay? And these sample probabilities we've learned actually, given certain criteria, like p hat times q hat being greater than 5, the idea is that these sample probabilities actually will make for us a normal distribution. Again, given certain criteria that being met. So what's the idea behind this hypothesis testing we're looking at? Well, this is all fine and well so far. We have our traditionally held value of 0.5, right? It is traditionally believed there's a 50% chance that you get a heads. And we've played the game 3 times. And in those 3 times that we've played the game, I had a 42%, a 53%, and a 47%. And we can understand that every time we play the game, we're probably going to get a slightly different probability of heads happening within that specific game. But the overall probability is still 0.5. Now, what does hypothesis testing have to do with this? Well, the idea is what happens if we play the game a 4th time? And I get 98 heads. Hold on. 98 heads, that means within that game there was a 98% chance that I would get heads. You may not understand what hypothesis testing is yet, but you understand that, hold the phone, that shouldn't have happened. That's weird. There's no way, if I'm using a fair coin, that there should be a 98 out of 100 flips turning out to be heads. Now, the alarm bells went off in your head when you see that, but not in the other 3. Why? Well, because 98 is way off from 50%. Our traditionally held value is way off from our population parameters, way off from our statistic. Our traditionally held value is way different than the value we actually saw happen in front of our eyes. This is the idea with hypothesis testing. If, unlike the other 3, I flipped a coin 100 times and 98 times it turned out to be heads, you're going to sit there and say that's not a fair coin. What are you really questioning? You're questioning the traditionally held belief. You're saying that the coin I'm using does not have a 50% chance of landing on heads. If it landed on heads 98 times, you're probably saying there is a greater than 50% chance. For sure, we might not know the specific number, but you're saying there ain't no way it's 50. It's got to be bigger. Or if I got 2 out of 100 turned out to be heads, you're going to say, no way, it's got to be smaller. It's got to be smaller than 50% if out of these 100 flips, only 2 of them turn out to be heads. You are rejecting the traditionally held belief that 50% of the time when you flip a coin, it turns out to be heads. This is the idea of hypothesis testing. We have a traditionally held belief for something. Let's say it's flipping a coin. We have a traditionally held probability, but if we get certain sample data, we might question and ultimately reject our traditionally held belief. Okay? The first 3 times we played the game, you're not thinking at all about questioning the traditionally held idea that 50% of the time I flip this coin, it's going to be heads. But the minute I get 98 heads, you all of a sudden are going, wait, that coin's not fair. There's no way the probability of getting heads is 50%. So what we're going to explore is, when do we reject that traditionally held belief? What mathematical evidence do we need to reject that traditionally held belief? So the question maybe rattling around in your brain is, well, obviously with 98, we're probably going to reject it. But what if this was 67 out of 100? Well, we look at that and we go, if I sat here and flipped a coin 100 times and I got 67 heads, you're probably going, that's high, but I don't know if it's enough to say that 50%. The question becomes, where's that cutoff point? And the way we're going to explore that is we're going to look at the distribution of p hat. Okay, we're going to look at the distribution of p hat. All these sample proportions create a distribution. We talked about this in chapter 8 and chapter 9, the idea of a sampling distribution. And since the sampling distribution is normal, we are going to be able to look at it and say, okay, at what point should we reject our traditionally held belief? And at what point should we, or at what points do we go, you know what, that wasn't maybe necessarily really close to the traditionally held belief, but it's not enough evidence to reject it. So this is going to be the idea for chapter 10. Good luck. And as always, let me know what questions you have.